Good afternoon, everyone, and welcome to the first session of Credit Risk Model Development using SAS. I would be your facilitator for the sessions going forward. My name is Tanmay Ganguly, and I welcome you all on behalf of X11 Analytics to the CRM sessions. Looking forward for a very rich knowledge exchange session. All of you, all of you, right? So, uh, so before we just start off with the sessions, uh, like every session, I take a couple of clarification confirmations. Number one, am I audible and is my screen visible? Great, great. So I believe I have Anirudh, I have Prakash, and I have Preeti with me. And one more person is Kumar Piyush is supposed to join with us. So I think he would be joining in any time. So in the meanwhile, let us just get started. So before I just start off, so I would just like to ask you one thing to you guys. That are you guys a part of the demo sessions that had happened with me sometimes back? So did you guys all attend the demo session? Okay, great. So I think it was only Prakash from this batch who was there and Kumar Piyush. So okay, before I just move on, you know, before I move on, let us just have a quick round of discussion on the type of material, on the way the classes are going to go forward. So basically, the classes are going, the medium through which the class is going to take place is through this GoToMeetings platform, right? And apart from that, the most of the class discussions and everything they are going to happen using so they are going to happen using this particular framework. So this is your what should I say, this is the online platform that we use, and this platform is called the Scribbler platform, right? So whatever classes go on, right? So they can always be, we can always convert the classes into PDF documents. So basically, whatever board work would be done would be shared to you over the week uh, as a Scribbler board work session, right? And from there, what we'll do is, so apart from this. Yeah, so apart from this, we will also be working around with the SAS editor windows, right? So you will get well documented SAS editor windows for your learning purposes and so on, right? So over here, so the whiteboard work and the PDFs are going to be one of the most important documents that would be shared out to you. Apart from this, all the recordings for these sessions would be hosted on the Google Drive. So as your sessions begin, so we will keep on uploading the recordings on Google Drive so that you can actually access the recordings. You have the class notes, you have the relevant SAS editor windows, and so on. Right, so you would be able to access everything. So all study materials, all documents, they are available to you till eternity. So you need not worry about it. The only thing that you need to worry about is how would you prepare yourself for during this module. What are the knowledge? What are the core knowledge building that will happen during this sessions and so on, right? So so that is roughly the types of material that would be given. The sessions would be delivered through this delivered online. Now you can always reach out to me with your queries at Conmoy at TextLab Analytics. Also, going forward, you can avail. You can actually take my number and you can, you can connect with me over WhatsApp or Facebook, whatever you feel comfortable doing. I'm pretty active on LinkedIn, and you guys can add me to your network as well, and you can chat with me over LinkedIn as well. or you can give me a buzz. So I am available with you guys all over whenever you need my assistance, right? And I have and you will get access to all the recordings. Having said that, so we will start. So when we start this particular module or with this particular course, let us all be on the same page that we would start right from the scratch. So my assumption during this sessions would be that no one in this platform knows what credit risk modeling is, and I would start right from the scratch, right? So if you guys do have an idea of what modeling is or how the credit risk platform works, feel please wait until so you have to you might have to wait on until you reach the more advanced portions, but as long as it goes on to the basic portions you might have to just sit through it, right? So that is all from my end, right? So before we start, so basically what I would like to know is that whether you guys have any questions at your end. So anything that you might want to know before the sessions start, and then how do we go about? So then after that we'll take up all the technical discussions and stuff. Great, Preet. I did have quite a discussion with Bakash sometimes back, if I'm not mistaken. So we'll have as I go on, right? As queries start coming up, feel free to reach out to me, right? Okay, great. So great. So before I start off with the credit risk modeling sessions and stuff, so just let me lead a framework for the discussion going, right? So how is the module structured? First of all, I'll just give you a brief overview of how is the module structured and what is the part with which we will start off our discussion with. Right? So basically, the module comprises of two parts. One is the statistics or the statistical modeling part or the elements of statistical modeling. And the next thing that I have over here is the next thing that is required is the core risk modeling part. So one of the part of the discussions will be statistics, or statistical modeling elements, stat. The second part of the module will be business scorecard development. So business scorecards. So when I talk about business scorecards, what I mean is scorecards like application scorecards, then behavior scorecards, collection scorecards, etc. So business scorecards. And the third part will involve the regulatory model development, which is model like PD, LGD, VAD models, and also it will involve the regulatory models like IFRS 9, etc. So the third part is, or the third part talks about the regulatory model. Okay. So coming to your question, so before I proceed, I'll take the question up that Aniruddha has. Aniruddha has. So that is So basically, we don't have anything directly. This model does not cover loss forecasting per se, but different techniques related to loss forecasting, such as such as expected loss approach and provisioning methods, those are discussed, like roll rate analysis, to some extent vintage analysis is discussed. However, the time series model, so forecasting using time series model, etc., does not form a part of this module. The time series portion is discussed under the market risk module, where if we talk about application of the time series models to the financial for forecasting financial variables. Over here, we do not talk about loss forecasting per se, but we do talk about the provisioning models like the ALLL models, IFRS 9, provisioning, etc., in light of the PDLGD EAD models. However, for developing the scorecard, we require some part of roll rate analysis to go on. So, and that is where this, roll rate analysis, vintage analysis is required, which are used as loss forecasting tools, and those are discussed during the sessions. Guys, just give me a second. I just replied to your question. Just give me a second. Okay, so I have a couple of questions over here. So yes, Prakash, we would be talking about limit setting and credit strategies. However, that would not be a hands-on part. We would be discussing it as an extension of the behavior scorecards or the behavior scores, and how are behavior scores used in account management strategies. The next thing that I would be talking about, risk-based pricing, is outside the scope of this module, because that's a strategy part. That's a, that's the role of the strategy team to look into it, right? Or how decision systems are constructed. My objective over here is to focus on five core risk models which are used either for executing the business, for taking business decisions, or are used at different regulatory levels for maintaining either provisions or for maintaining capital reserves, right? So that is precisely what the objective of this module is. So these questions like limit setting, credit strategy, risk-based pricing, or decision-making system, these mainly form a part of the strategy team, and those are core. That's a separate part. So my objective over here is not to develop strategy models, but to develop risk models which can be leveraged by the strategy team for taking strategy decisions. However, as I discussed the risk model development, say I'm developing an application scorecard or I'm developing a behavior scorecard, I would be talking about the role that these scorecards play in taking strategy decisions. Right? How does these model help the strategy team to take the current decisions? Right? So this is what the this is what the basic idea of the module is. Okay. So having said that, we can see. So basically, these three are the key areas that we will be focusing on. So when I talk about statistics, or when I talk about the statistical discussion, right? I'll talk about over here. We'll talk about the basics of statistics. So over here, we would actually explore different concepts, different basic statistical concepts, which will later be required going forward for model development, model validation, etc. So basic statistical concepts. Now, when I say basic statistical concept, I do not only mean basic concepts like mean, median, mode, but basic statistics, so which includes inferential statistics, the basic theory of classical inference. This talks about predictive modeling techniques like linear regression or logistic regression, techniques which talk about testing of hypothesis, techniques which talk about statistical techniques and concepts which talk about basic descriptive measures, and so on. Right. So over here, our objective first will be to explore the statistical techniques. So now decision. So coming to your question, Preeti. So Preeti asked whether we would be covering shade as well. Yes. So basically, when I talk about basic statistical techniques, right? Uh, I use logistic regression as an just an example of a classification method. We will cover decision trees. We'll talk about shade. We'll talk about CART, their frameworks. How are they implemented, right? So, what are the different platforms on which these techniques can be implemented? So, basically, we will talk about shade in terms of chi-square techniques. When I talk about chi-square distributions, when I talk about the chi-square statistic, when I talk about association between categorical variables, that is where the role of shade comes in, right? However, when we are talking about when we are talking about segmentation, we'll talk about both about business segmentation and we'll talk about statistical segmentation as well, right? So this part is the most. So this part will comprise of core statistical techniques, right? And as we start off this module, right, you can take it that for the next 1 month, that is for the next 8 to 10 classes, we will be talking about core statistics, and it would be like we are talking about core statistical theory, right? So you will see different mathematical expressions. We'll get to see not only the mathematical expressions, but also we'll get to see their applications in risk. We'll talk about different statistical basics. We'll talk about different modeling methods and so on, right? So there will be a lot of these different exercises that we'll be doing, and with this credit risk modeling module, there would be a lot of emphasis on the statistical model development, right? So, how is a linear regression model developed? How is it that a logistic regression model is developed? How is it that a t-test is done? How is it that an ANOVA is done? What is the difference between a t-test and an ANOVA? What is the difference between a parametric test and a non-parametric test? What are the different basic measures of statistics? What are the different types of analysis that can be done on a data in risk? Also, so once we have discussed that part, right, means once we have discussed this basic statistical part, then we move on to talk about the scorecards, right? So when I talk about scorecards, I'll talk about two broad type of scorecards. One is the application scorecard. The application scorecard or the origination scorecard. And the second type of scorecard that we'll talk about is the behavior scorecards. The next part that we'll talk about are the behavior scorecards. Also, we'll talk about the overall behavior, overall importance of each of these scorecards. So, which scorecard is used where? Why would I need a scorecard? What are the advantages of using a scorecard, and so on. Then what we so once we have discussed the application behavior scorecards, what is a scorecard? What are the different model development methods? What are the different model validation methods, and so on? The next thing that we get to is the regulatory model development, where we'll talk about a lot of different models, which includes the obviously the most sort of the three suite of models called the PD, LGD, and the EAD models. So these are the three most sought after models that we can. So these are the three broad models that we will talk about. Now, talking about these models and their implementation on the SaaS platform, right? So these are the group of five core models that we will talk about whose end-to-end development and validation right up to implementation we will be talking about. Now, once I have an idea of the PD, LGD, and the EAD model development estimates, right? Once I know how these models, what these models are, from there I can actually compute my expected loss. Right. So once I have an expected loss, from there I'll try to cover the provisioning models like the ELLL models, the IFRS 9 models, how are the provisions is, designed differently under each of these regulations, and the more recent CECL model as well. But I cannot promise whether I would be able to cover a hands-on implementation because of the time constraint, because developing these five core models and the basic statistical portions into it would itself be a very tough job. So therefore, what I would try to do is I would try to develop this model. So first of all, my objective would be to develop the statistical framework. The second part would be to develop the application and the behavior scorecards, and then the objective would be to develop the PDLGD and the EAD models, right? So once these developments are done, then we'll talk about the provisioning models. And when we talk about provisioning models, that is where we bring in the concept, we bring in regulations like ALLL, that is, we talk about, you know, the CECL models, and then we talk about the IFRS 9 models and how these provisioning models are different from each other, right? Also, after that, we also try to develop not a hands-on but an understanding of the or and trying to theoretically understand the CCAR model development, CCAR DFAST model development, right? So how to stress test the particulars, how to stress test a regulatory model, right? So that is something that we'll also explore. So depending on the time frame that we have in hand, with us we'll try to develop an end-to-end implementation oriented approach. But on the other hand, if we are able to, develop like a theoretical understanding or a framework of the steps, that will also be helpful. So everything depends on the time that we have at hand. But our core objectives, first of all, would be to develop the basic statistical section, the application behavior scorecards, and the PDLGD models, and then we'll draw up these extended portions as well, right? So that is the plan going forward. But as I discussed earlier as well, each of these models will have, while we are trying to develop these models, what we need to ensure is that, so basically what we talk about initially is the basic statistical portions, right? And this statistical portion, the building up that statistic, the section one of the module, will take us around a month or so. So basically, you can expect that over this month, from starting today, over the next of the time frame, we will be working solely on statistics, right? Examples from credit risk will be coming up here and there, but the core credit risk part we'll start talking about only in April. But in this month, we'll start first framing the idea of the overall descriptive statistical. So basically, we'll talk about the statistical framework which is required for model development going forward. Clear? So is the roadmap of this module clear? So how do we approach the problem uh, from beginning to end? This roadmap clear to you all? Prakash, Preeti, Anirudh, are we on the same page regarding the approach? Okay. Okay. So to your question, Prakash, why have we selected SAS as a tool? Okay. So basically, there are a few reasons why. So first is uh, SAS as a tool is very easy to understand, right? It is a very flexible tool and makes data management extremely easy. The third is that most of the risk models that I have worked with, right, I have always worked with SAS. And there are certain coding protocols, there are certain coding controls, and this entire picture of model development and implementation is very easily understood in the SAS framework, right? And you would see that most of the banks, most of the large organizations who are working with regulatory model development in specific are deploying SAS till now, because no, the only challenge with SAS is its pricing and its expensive nature. But otherwise, from any possible end that you look into the software, it's very easy to work with and understand, and it has a very nice interface which helps report generation and compilation very easy. So I do not that does not imply that R or like Python does not have data interpretation or you know a good data representation interface, but it is the I mean I have so most of my experience has been around SAS, and I have seen how models are implemented in SAS, and that way it would be that way it would be more helpful uh, from the participants' perspective, because it would be more easier and more relevant for me to guide them all along in this particular platform. So that is the reason why we chose with SAS. However, yes, we are working towards R, right, and we are trying to replicate this model on R as well. But that is going to take a good year's time to do. So basically, as of now, the only implementation platform on which this module I am delivering is using SAS. Clear? Okay. So when you are practicing this module at your end, right, there would be a support from our end where we'll help you install the software, right? So you can actually access the software, and we'll actually help you install it into your system, and you can practice on your laptop. So for the SaaS installation side of things, please reach out to Vivek or Shubhrajyoti. They'll guide you to the necessary team, right? Because that is one part that I do not really see. So they oversee those installation and all those support part, and then what I do is mostly focus on technical side of things. So I generally use SAS 9.0 for my coding purposes, but you can access SAS 9.4 as well with us. I generally do not use any kind of the drop down versions. I generally use the base SAS coding part because coding or understanding the coding logics help you get a better grip of things. Since I use it solely for training purposes, I solely rely on the base coding version, that version where I can develop the coding end to end, where I have to manually code everything up. So that gives you an insight into the logic of the stuff, which may not always be clear if you are doing it manually. I mean, if you're doing it using a drop down kind of software, right? So I have worked both on easy as well as base SAS. So I worked on SAS 9.4 itself, uh, and I have frankly found this base SAS 9.4 to be more user friendly than using drop down, using these nodes and creating packages and creating problems. So I generally prefer, if you ask my personal preferences, I prefer this basic version of SAS where I can code everything on an end-to-end basis, right? Okay, so just a quick question. Of the four of us over here, like how many of us are conversant with SAS? Prakash, I know, is very new to the software. Apart from Prakash, Preeti, Anirudh, Kumar. So, how many of you are okay with SAS or have worked with SAS? Or are you guys new to SAS? Okay, great. Not a problem. But however, you will have. Okay, okay, Kumar. So, anyways, even if you're new to SAS, it would not take you much time to pick up pace with it, right? So, need not worry. So, you have one whole week or a couple of weeks to, to reach out to Vivek, Shubhrajyoti and get SAS installed in your systems, right? So, write out a mail to them, right? Keep me in the CC, mark me into it, and the necessary team members will coordinate with you. They'll reach out to you, they'll tell you to download some stuff, basic stuff, and then they'll help you out with the installation side of things, right? So how many of you are based out of Gurgaon in this team? Delhi or Gurgaon? Okay, so all the three of you are based out of Gurgaon. Prakash, Preeti, Kumar. So what you guys can do is you can directly pay a visit to the DexLab office, right? Be it on a weekend or a weekday, whatever works, right? And get your SAS installed directly from the team. So just first let them. Just first take the required specification from them, right? If you see your system is matching up, just go down and get it installed, right? So if you require to download something else additionally, you can do that previously before you go, and then you get the software installed over there, right? So installation should not be a problem. Okay, great, great. So having this sorted. Okay, so any other questions on this functional side of things? Clear? Okay, great. So let's get started. Right? So, starting today, we will be talking about the basic statistical techniques required for model development, model validation, etc. Right? So, basically, the statistical portion that we'll talk about is divided into three main parts. One part that we'll talk about is the descriptive analysis, or as we call it, the descriptive analytics, or the descriptive statistics. Right. So, talking about the descriptive statistics, we need to understand what is it actually all about. So, what are we describing, and how are we describing, and why is it called descriptive measures? The second part, or the second kind of statistical theory that we'll be talking about, is the inferential statistics. So, what are the statistical theories and what are the statistical concepts that we need to infer about something or someone? So, that is where we talk about inferential statistics, right? And the third kind of statistical modeling that we talk about is the predictive modeling. So in predictive modeling, when I talk about predictive modeling, I'll talk about linear regression and logistic regression. But I'll also try to cover some of the advanced statistical modeling techniques, right? So I'll try to cover methods like beta regression. I'll try to cover techniques like survival analysis. I'll try to cover techniques like random forest, gradient boosting, and I'll try to create a framework of neural networks. What are these? So I'll try to bring in all those statistical methods, right? So this part, or this under or exploring these statistical methods which will come down to us when we require to develop credit risk models, right? So this discussion might take up quite some time, right? So as we go through each of these concepts, please go through these concepts over the week and start framing your idea about them, right? So the concepts that we discussed during the sessions, feel free to go back and start working around that, right? So I do not want to hurry through the statistical portions. We'll take it gradually. If you have any questions, if you have any queries, feel free to reach out to me. Stop me during the classes, ask me questions, put your queries on the chat box, but ensure that you get these concepts very clear before we move into application and behavior scoring. Otherwise, when you reach over here, even if you don't have these concepts very clear, then you'll get bombed off. So do not do that. So basically, let's start with the concept of a descriptive statistics. So what is this concept of descriptive statistics that we talk about? So before we talk about descriptive statistics, let's take a business problem, right? And in respect of that business problem, let us try and understand descriptive statistics. So first of all, the word descriptive statistics is very self-implying, right? So when I talk about descriptive statistics, it means that I'm trying to use these statistical techniques. I'm trying to use basic statistical methods, and using those basic statistical methods, I'm trying to describe something. So what am I trying to describe? So what I'm trying to describe essentially is variables. So my objective is to help people understand. So my objective is to take a variable and try to understand its state, or to describe its state. So one key area where when we can think about descriptive statistics, or when we are describing something, is a business portfolio, right? Is the business portfolio or the portfolio of a bank? The portfolio of a bank. So basically, you would know that most of the banks, so all banks, they release monthly, quarterly reports, right? Which goes up to the management to get an idea about how the business has been performing, right? So assessing or understanding the overall state of the portfolio is very important. So when I try to assess or when I try to describe the picture of a portfolio, that is called a portfolio analysis or a portfolio. So that is called a portfolio analysis. So what are we trying to do in a portfolio analysis? What we are trying to do in a portfolio analysis is we are trying to describe the state of a banking business. So before going into that, let's try and understand what exactly is a portfolio. So when I talk about portfolio of a bank, what it means is I'm just talking about a collection of loans. So if you think about it, you'll see that we often say that okay, I am talking about the uh, credit card portfolio of a bank or the personal loans portfolio of a bank. So what exactly is the credit card portfolio or a personal loans portfolio? It is nothing but it's a collection of credit card loans or it's a part of the personal loans, right? So a collection of loans is called a portfolio. So if there are a set of loans which has been extended out, if there is a part, if there are certain number of loans which has been extended out, then I need to assess what exactly is the overall feature or what exactly is the average behavior or the average performance of the portfolio. So when I want to get this kind of a overview, that is where this portfolio analysis becomes important. That is where these descriptive statistical measures become very important. So descriptive statistics help us describe a particular variable. So it helps us describe the variable. And that is why it talks about, or that is why it's called descriptive stats, right? So over here, when I talk about descriptive stats over here, so when I talk about these descriptive measures, so there are two questions which come up to us. Number one is how is it that I can actually describe a portfolio of loans or a collections of loans? How do I describe? And the second is what are the ways or what are the techniques of description? So what are the techniques of describing the portfolio? So in the first question, what I want to understand is what are the matrices of describing a banking portfolio? So a bank's portfolio is one of the most important measure of describing a bank's portfolio is the number of accounts. Now, the number of accounts will actually give you an idea of the expansion that the portfolio has had over time. So, if you look into the number of accounts which the bank has booked over a period of time, right, or with the number of accounts which are on the books of the bank over a period of time, you will get an idea about the portfolio's description, right? So over there, what we have is, so the first and the most basic measure of assessing the portfolio behavior is the number of accounts. So larger the number of accounts are over time, you would or by looking the rate of the increase of the number of accounts, you will be able to identify that how has the portfolio grown over a period of time. Now, after you have looked into the number of accounts, the next part that we look into is the total receivables that the bank has, or the total balance, or the total amount of credit that the bank still has outstanding. So, the total number of receivables, the total number of receivables, the total number of receivables are, or it is the, you know, so total receivables gives us an idea about how much the bank has actually lent out over a span of time. Now, the first one shows the expand. The first these two measures, they'll give us an idea about the expansion of the. If I look into the trend of these accounts, I'll be able to identify. Okay, this is how this particular uh, behavior, or this particular portfolio is behaving. Now, just by looking into the total number of accounts and the total receivables may not always give me an idea. Therefore, what I need to have is I need to have some summarized view of the portfolio. And that is where the concept of average receivables actually come in. So this is the part where we talk about average receivables, or receivables per obligor that the bank has. So if you see that the average receivables has increased, you know that the per person outstanding balance has increased over time. So on an average, the bank has actually lent out a higher portion or a higher amount of credit to a representative individual. So when you do this average receivables, right, you are able to get a more clearer picture of the portfolio, right? So when you are finding out the average receivables, so what are you doing? You are actually aggregating the behavior, actually aggregating the behavior, right? So the descriptive measure, the objective of descriptive measures is to aggregate the behavior of a variable, or to capture the aggregate behavior of a variable. So for example, I'd say that the bank has earned huge losses. So the first question that I want to understand is how huge are the losses? And when I say huge, how do I define this huge? So obviously, if you're defining something as huge, you are referring to a normal or an average as a benchmark. So what is the average loss that the bank generally earns on a year-on-year basis or on a quarter-on-quarter basis, and how much has the deviation been, so that you call this a huge deviation? So this is something that we are trying to develop over here, right? So the basic objective of descriptive statistics is to help us capture the aggregate behavior of a variable. Over here, the variable was receivables, and I have used average as a measure to aggregate, or to get a picture of the aggregate picture of the receivables, right? So over here, therefore, whenever I talk about descriptive statistics will always help us get a clear picture of the overall behavior of the of a given variable. So now the question comes in is, what are the descriptive statistics? What are the descriptive measures that we want to look into? So we will explore three kinds of descriptive measures. One is the measures of central tendency. So measures which gives us an idea about a central value about which all the values are concentrated. So the first is the measures of central tendency. Also, these are known as the measures of location. The first type of descriptive measures that we talk about are the measures of central tendency, which gives us, which helps us summarize the central tendency of the data. So what do we mean by central tendency? To that I'll just come down a little later. So the next is the measures of dispersion or variability, right? Now obviously there will always be a dispersion about the observed average or the observed central value, right? So the next part is the measures of dispersion. So if I want to evaluate the behavior of a variable, I can not only it is not always that I use the central measures, but I will also look into its overall dispersion, right? The next part that I have over there is the next type of measure that I look into is the measures of asymmetry. Measures of asymmetry, where we talk about the skewness and the kurtosis, right? So over here we'll just talk about skewness initially, measures of asymmetry. So these are the key three types of measures that we need to talk about. So that's the measures of central tendency, the measures of dispersion, and the measures of asymmetry. And each of these measures always gives us an insight into the behavior of a variable, right? So they always give us one kind of, so they help us assess behavior of a variable from one aspect or the other. Clear? So up to this point, are the discussions clear? So are we clear on the concept of what is a descriptive measure, what is a portfolio, and what is it that are we trying to do using, or what is it that we are trying to achieve using descriptive statistics? So is this part clear to us? Then I'll move forward with each of these concepts. Great. Okay, so let's start talking about uh, the descriptive measures, or I mean central measures of central tendency. So what do we mean by the concept of what do we mean by central tendency? What is so central about this tendency? Say for example, let us take a set of values, right? Say I take the value, consider a value like 29, 31, 30, 28, 32, right? So there is a variable x which takes all these values. Now, if I am to summarize the behavior of this variable x, what do I need to know? The first thing that I need to know is that what is that value around which all the other observations of x tend to clutter about. And that is the measure of, that is called a measure of central tendency. So a measure of central tendency will help us identify a representative value for a set of observations. So this will give me an idea about a representative value. So a value using which we can generate a representative value using which we can represent the overall behavior of the data. So a central value will be a representative value, and this representative value will help me will help me get a overview of the behavior of the variable. So that is what is a representative value or a measure of central tendency. So if I can find out that value which will help me represent the overall behavior of a variable, then I can say that around that value, all the other observations will be clustered. So over here in this case, 30 is the middlemost value around which all the other observations are clustering. Also, you can see that 30 is the average value that this data set has. The average of all the other values in the data set is 30. So basically, over here, what we have is the overall distribution. So over here, by looking into the central value, I can make an idea about what exactly is the overall behavior of the data, right? So this is what is called a measure of central tendency. So measures of central tendency helps us identify representative values for a set of observations of a variable. So using that value, you can actually summarize the overall behavior of the variable. And some very well-known measures of central tendency are mean or the average, the median or the middlemost value of a variable, and the mode. Mean, median, and mode. Now, if you think about all these three measures, you will see that all these three measures do one thing. They give us a representative value, which can be used to summarize the overall behavior of a variable x. Mean gives us the average value, median gives us the middlemost value, and mode gives us the value which is most repetitive in the data. So the variable or the value which has the highest frequency. Now that so if you look into these three alternate measures, you'll be able to identify that each of these three measures, right, be the mean, the median, and the mode, they help us gain a representative value for a variable x, and for obviously for a numerical or for a continuous variable x. On the other hand, on the other hand, there are other measures of other measures of central tendency as well. Now, mean, median, and mode are called the absolute measures. They are traditionally called the absolute measures of central tendency. So these are measures which give us an idea about the you know gives us an of absolute value as a measure of central tendency. Now, there are other measures of central tendency as well. So there are other ways of identifying the representative value. Those are known as the relative measures. So when I talk about the relative measures of central tendency, So the next is the relative measures. So the question that comes is, what are the relative measures? Now, within relative measures of central tendency, we have different measures like one of them is percentiles, percentiles. The second that we have is deciles, quartiles, etc. Percentiles, deciles, quartiles, etc. So basically, what are these percentiles and deciles? So in both in these relative measures of central tendency, what happens is the entire data is broken down into equal parts, right? And it is seen that where does the value lie in relation to other values in the data sets. For example, let's take percentiles, right? Now, percentiles in India has a special relevance because percentiles are the yardstick of performance in the CAT examination. And people, and IIM aspirants for IIM, they are always looking to have a score which is in the 99.99 percentile, or they're willing to get a 99 percentile or a 100 percentile kind of a thing. So what does this 99 percentile mean? So why are parents so happy when their students get 99 percentiles? So does that mean that their student has, or that their candidates have scored 99% in the exam? There are many people, many non-statistical people who do confuse it for the same, but these two are different. So what is percentile? Let's take the example of CAT, right? So what happens is, say in CAT, there are 1,000 students who have appeared in the CAT examination, and I got a 99 percentile marks. So what does that mean? What it means is that nine the marks that I have got is such a marks where 99% of the 1,000 students, where 99% of the 1,000 students have got a marks which is less than equal to mine, have scored less than equal to my score, less than or equal to my score, right? So over here it says that if I have obtained a, say I might have got 30 out of 100, whatever the marks is, but the others have got a marks which is lower than equal to that 30 out of 100. So it means that I have got a score where 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 99% of the population lie below me. That is precisely what the concept of a relative measure of dispersion is. So where you are looking into a certain marks or a certain value relative to the other observations in the data set. So basically in percentiles, what I am doing is I am dividing the entire data for of the students with their marks into 100 equal parts, right? So basically in each percentile there are 100 students, right? Therefore, in each person, so if I say I got 99 percentile, what it means is that I have got a marks X, which is greater than equal to the marks obtained by the remaining 99% of the population. So I've got a marks which is greater than equal to the marks obtained by 99% of the total test taking population. So over here it is 1000. So 99% of 1000 have scored a marks which is less than equal to mine. Right? So it's basically say 999%, 999 people have got marks much lower below me, lower than or equal to my score. So over here, when I'm talking about percentiles, I'm looking into the marks that I have got relative to what the others have done. So over here, in when I'm talking about descriptive measures, right, in terms of relative measures of central tendency, then I'm looking into the overall distribution of the values of the variables. Whereas when I'm talking about mean, median, and mode, which are the absolute measures, I'm just taking up all the values and I am just counting one single measure, which will help me summarize the overall behavior of the data set. Clear? So, is this concept of absolute measures of central tendency and relative measures of central tendency clear? Great. Similarly, when I talk about percentiles, another alternate measure or another alternate relative measure of central tendency is deciles, where in deciles you are dividing the data into 10 equal parts. So, if I am dividing the data into 10 equal parts, what it means is that say I have obtained a marks, I obtained a point at the seventh decile. What it means is that the marks that I have obtained is such that 70% of the population lies below my marks, or has got a marks which is less than equal to my marks. Right. So basically, one very important measure or one very important concept or one very important point related to these relative measures of dispersion is that if you are trying to do a relative measure dispersion, the variable must be sorted in its values. So the variable must be sorted. So either you have the variable must be sorted. So either your variable is sorted in an ascending order or in a descending order, but it must be sorted. So the sorting can be done both in a ascending or descending order depending upon what you actually want it to be like, and the other is descending order. So basically, if you say the example of cat that I have given, right? So if I say 99 percentile, what it means is the 0th percentile is the lowest value and 100th percentile is the highest value, right? So basically, the numbers have been sorted from highest to lowest. So the value below which 99% of the population lies. So that is where the values have been sorted in the descending order. Also, the values can start in the ascending order, right? So whatever it is, the first decile will mean that this value is a value such that less than equal to 10% of the observations lie below your value, below the value of the first decile. The second decile, what it means is that this is a value below which so much of the observation lies. So the sorting can be done in an ascending or in a descending order. And above all, above all, one basic advantage that these relative measures of dispersion has over the absolute measures. So these are what your absolute measures of dispersion. These are absolute measures, especially mean. So one advantage that relative measures have over absolute measures of dispersion is that these measures are not really affected by outliers or extreme values. Not affected by outliers. Because the overall shape of the distribution would be affected, but the basic measures like the 25th percentile or say the 50th percentile, that is a median value or so on, they are not affected by these measures. The reason being that the outliers, be it a upper end outlier or a lower end outlier. So it might be a outlier of very high impact, or it might be a outlier which is at the lower end. So it's a very small value compared to the other values. So which might create an asymmetry in the behavior of the data. So they do not affect these relative measures because you are sorting all the values in ascending or a descending order. So anyways, outliers would lie either at the end, I mean the upper end, or at the lower end. So the middlemost values are not really affected. Therefore, these measures are not affected by outliers. So let me put it as extreme values. So these distributions are not, I mean, these measures are not affected by the existence of extreme values, right? So let's see what I mean by this. Let's say, okay, so over here, Piyush has a question that any advantages that absolute measures have over relative measures. Yes, Piyush, there are advantages. I'll just come to. I'll just come. So over here, see, let's take this particular case. Let's take a case where I have a variable x. So one value is 5. Then I have a value 105, and then I have a value 10, right? So I have this value. Now if I have this series, you will see that 5 and 10 are two observations which are very close to each other. But 105 is a value which is creating, which is clearly a very heterogeneous value compared to the other two. This value is very different from the other observations of the data set. So over here what I have is 505 and 0, right? So basically 105 is a value which is creating a sudden change, or it is creating a sudden uh, variation in the data, right? Now if I use mean value, right? So x bar will be over here. What is x bar? X bar over here is 40, right? So 105 plus 5 is 110, plus 10 is 120. So over here this is 120 divided by 3 is 40. So x bar over here is 40. Clear? But if this 105 was not there, so if I remove 105, what is the x bar? Without 105, the value x bar would have been just 7.5. So what you can see is that the impact of this external value, or of this heterogeneous value. This is the value of this type of a value which we call outlier or an extreme value. So the existence of this kind of an outlier is something which is impacting the behavior of the data or behavior of the variable. Now, when this outlier or this extreme value is over there, it is suddenly creating a variation in the mean value as well, right? So you see that this value 40 is more representative of 105 rather than representative of 5 and 10. So in this case, the representative capacity, the representative nature of the mean has been tampered or has been distorted by the existence of an outlier. So if the outlier value had not been there, then that x bar would have actually been 7.5, right? So this should have been 7.5 and around 10, but the value, but given 105, the overall variation has increased so much that the overall mean has shifted to 40. Now over here I can clearly see that this is a big challenge, right? So the value of the mean, the nature of the central tendency has got distorted because of this central value, right? So the existence of outlier distorts mean as a central tendency. So it distorts the representative capacity of the region. Distorts the representative. Distorts the representative capacity of the mean, right? So what we can see is that the mean of a variable can get affected by the outliers or by the existence of extreme values. Now let's look into median, right? So median is a relative measure. So median can be considered both as an absolute measure or it can also be considered as a relative measure of central tendency. So if I am looking to a median, what will happen? Now if there is median, if I want to find out median, then first of all I'll arrange it in a ascending or a descending order. So it is 5, 10, and 105, right? 5, 10, and 105. Now, what will be the median? The median is the middlemost value, right? So the middlemost value in this distribution is nothing but 10. Even if you arrange the data set in the descending order, this is exactly going to be the same thing. That is 10 is the median. So what you see is that median gives us a better reflection. Median gives me a better reflection of the central tendency. And median is not affected by the external or by the existence of outlier. So median is not affected by outliers. By outliers. Therefore, if your distribution is a very skewed distribution, then it is suggested that we use median as a descriptive measure rather than a mean. And median is nothing but the 50th percentile value, or it is nothing but the second uh, or the fifth decile or the second quartile, right? So basically the so median basically is a value which divides the data into two parts. So 50% of the value is below the median value, and 50% of the values observation in the data set is above the median value. So this is the value which splits the data into two halves, and hence it is considered to be, a kind of an absolute measure, as well as it is also considered to be a relative measure, though it's more relative measure in nature. Now, therefore, these are the three basic descriptive measures: mean, median, and mode. And with the relative measures, percentile, deciles, and quartiles are the more are the most basic measures which are there. Now, the question that comes out is that in risk, right? In risk, so we are talking about credit risk over here, right? So in risk, which is the better measure of central tendency to use, right? And what exactly and why is it that always, even when median is available, we have to report average values as well? So what exactly is the meaning? So what, how does this work out? So what is the advantage of median over mean, or what is the advantage of mean over median, right? So basically, one problem with median is that median is itself not real. I mean, the reliability of median might become questionable if there are even number of observations in the data, right? Because there is odd observation, therefore I have taken this 10, 105. However, if there was four observations, then computing the median would have been a bit of a challenge, right? Also, also, one basic advantage of mean is that now, in for median, if you look into median, median does not look into the overall distribution of the values, right? It just looks into the middlemost value. So it gives you a very partial information about the central tendency, or as a measure of central tendency, median gives you a very partial kind of a information, because it is just focused on the middlemost value of the distribution, or the or two middlemost values, and from there you compute an average and you get to the median. But one advantage of mean is that mean uses all the observations in the data set. So an especially arithmetic mean uses all the observations in the data set, and thereby it reports an average value, right? So when it reports an average value, that is where this variable becomes, that is why mean becomes so widely used as a measure of central tendency, right? But again, mean often tends to get biased towards the higher end values if there is a skewness or an asymmetry in the distribution, right? So if there is an element of heterogeneity involved in the variable values, then mean tends to get biased towards the upper end values as well. So there are both advantages and disadvantages of these respective variables, right? However, when you want to frame an idea about the behavior of a variable, when you want to describe the overall behavior of a variable, we need to look not only into mean or median or mode separately, but we bring all the three together. And from there, what we do is we frame an idea about the behavior of a distribution. And the most important stuff that we need to assess about a distribution is that whether our distribution is symmetric or not. So whether a distribution is a symmetric distribution or whether is it an asymmetric distribution, that is what we need to understand over here, right? So this is where the role of mean, median, and mode comes in. So next what we'll do is we'll connect this concept to understand how is it that we can actually use these measures of asymmetry to take the next stage of our decisions, or how is it that we can actually use these descriptive measures to form an idea about the symmetry of our distribution, right? Great. So just give me a second, guys. I'll just start. Give me a second. Okay. So let's look into. So as I was saying, let's look into how this measures of central tendency can help us frame idea about a distribution. So what is a distribution? A distribution is nothing but it's a when I talk about a distribution, I simply mean a frequency distribution, right? So basically, how do we obtain a frequency distribution? How would a frequency distribution actually look like? So, so let's create a table over here. So over here, what I have is the variable x, and I have the variable frequency, right? So basically, say x takes different values, x1, x2, like this, x3. If and over here we define another measure called the relative frequency. So what is the relative frequency? The relative frequency is nothing but it shows the frequency of occurrence of a variable relative to the total number of occurrences. over here, this measure is called the relative frequency. Right? So over here, what I have is f1 by n, right? So similarly, over here you'll have f2 by n, etc. And if if you write this, you will have fn by n. So this particular table, which contains the values of the variable x, which contains the frequency, and which contains the relative frequency, that is called, this table is called the frequency distribution table or the relative frequency distribution table. Excuse me. So this is called the frequency distribution table. Now, from this frequency distribution table, we can actually try to find out what exactly are the overall behavior of the variables. Right? So over here, what I have is frequency distribution. So when I plot these values of x and the relative frequencies over here, what I'll get is the frequency distribution or the relative frequencies. So let's look into this graph. So I'll just create a graph over here. Right. So over here I have is x. So over here you'll have the values of x, and over here you'll have the values of the relative frequency. So over here, as I plot these frequencies, what I'll get is something, a distribution, so like this. Right? So this is known as the relative frequency curve, or as we call the frequency distribution curve. This is also known as the observed frequency distribution, because you are constructing this observed frequency distribution from the observed values of a variable. This is the observed frequency distribution or the observed distribution. So whenever we talk about, so as we go ahead, we'll in this, so you will see that we talk about a lot of, okay, what is the distribution of this variable, what is the distribution of that variable. So you know that for most of the time what we are talking about is the observed frequency distribution. Clear? Now, how is it that we can actually use these descriptive measures to understand the shape of a distribution? So obviously, at the point where a frequency observed frequency distribution peaks up, that point is obviously the mode of a distribution. So over here in this graph, if I look into it, I can say that this is the mode of the distribution. This is the mode of the distribution. Now over here, what I have is, now the median will be, so along this variable, along this line, x takes all the values, right? So the midpoint of this line will be the median. So over the median of the distribution, will be somewhere over here. So this is your median. And then over here along this line, the mean of the distribution is here. So I'll call this M. M is the mean, ME is the median, and mode is the mode, right? So basically what I see is that for this distribution, the mean, median, and mode are different. So the median mode happens at at one end, the median is the midpoint of the line, and mean is towards the upper end. Now, basis whether the mean, median, and mode are very close to each other and whether they are more or less equal or not, or whether the mean, median, mode are different values or they are different from each other, what we can do is we can define whether a distribution is a symmetric distribution or an asymmetric distribution or an asymmetric distribution. So the graph that we have constructed over here, this graph is a graph of an asymmetric distribution. Asymmetric distribution. Right? So this is an asymmetric distribution. So let's see what causes an asymmetric distribution, what causes a symmetric distribution, right? And how is it that we can frame an idea about both these measures from the discussions that from these descriptive measures. So let's try to understand the asymmetricity and the symmetricity distributions from the core first, and then we'll connect them back to the mean, median, and the mode concept, right? So what causes asymmetricity in a distribution? Why will a distribution be asymmetric? Let's look into this distribution first. So I have one example over here of this x and the other example I have over here. Right? So one example is this, right? So let's draw a graph of this distribution. So what I'm doing over here is I'm just trying to plot these distributions over here. So let's say this is 30 over here, right?
So at 30, what I do is I construct a histogram over here. 30, let me construct a histogram. The next value that I have over here is 31, right? So I'll conduct a next value over here, 30. The next value I have over here is 32. So I conduct a value which is 32. Similarly, over here you will see there is this value 29 about 30, right? So I write it like this. And then what I have is 28. Right. Now if you have a look into this distribution, right, you will see that this variable or the distribution or the values are distributed very symmetrically about this value 30. So most of these values are lying around 30 or so. So obviously what happens is, or we can say that all these values are very homogeneous in nature. So they are lying all are circling about 30. So the number which is around 29, 30, 31, 32, 28 like this. So all around 30 the number is spread out. So all these numbers are very homogeneous in terms of their nature, right? Say for example, if I think about it that these are the marks of a student out of 100, then a person or then a student who is getting 28 or a student who is getting 32 is very homogeneous in terms of their behavior, right? So therefore, this distribution is a symmetric distribution. So if I actually join a curve connecting all these graphs, all these bars, you will see that the distribution that I get is more or less very symmetric in nature. So what does this symmetric means? Geometrically, it means that if I split this distribution from between, the shape of the distribution to the right hand side, with this, the right hand side of this, and the one to the left hand side will be very similar in shape. So there would not be much of a variation, right? So this is where, I get to see that the distribution is more or less symmetric or homogeneous in nature. And the intuitive interpretation of this is that this distribution is homogeneous. In nature. Okay. So I have a question from Piyush. Shouldn't this distribution be a straight line as frequency is 1 for all the values and relative distribution should be 0.2, right? Right, Piyush? Absolutely, this should be, you know, a distribution like that, right? So everyone should have the same relative frequency over here. But what I did over here is just to bring in the shape of the distribution, I did that arbitrary construction. But ideally, yes, you are correct. If I am to go by the actual calculation, it should be a 1 by 5 for each, right? So basically, what happens over here is, the relative frequencies would differ accordingly. So over here, so since the values are, over here discrete in nature, you are getting into this shape. But however, for the values, if they are continuous in nature, this distribution would ultimately, this looks like it would ultimately go and look like a normal distribution, and that the values will be, because if 30 is a mode, right? So over here, the way I've written it, 30 cannot be a mode of the distribution, right? Because over here all the observations are the same repetitions. So the mode is actually undefined for this distribution. But again, the values are all symmetrically distributed about 30. So basically, it is generally seen that the middlemost value will have the highest frequency if this is to be a very symmetric normal kind of a distribution. So my idea over here is just to construct it to explain the concept of a symmetric distribution. And my idea over here is that all the values are concentrated around 30. So over here 30, if I take the average value, then average 30 is a good representative value for the set of observations. Clear? So when I come to the data sets, and when I start constructing the frequency from the data, there I would show the actual relative frequency distribution and everything, and there the thing would be more mathematically accurate, right? So over here I'm just trying to show you from the figures that what exactly a symmetric thing would look like. So that is okay. So can we conclude that for symmetric distribution, mean, median, and mode will be the same? Precisely, Kumar, we can actually conclude that for a symmetric distribution, the mean, median, mode will be theoretically they will be the same. However, in real-time data, you do not get the mean, median, mode is exactly the same, but they are very close to each other if a distribution is symmetric in nature. And theoretically, and this distribution has a symmetric distribution has a very special name in the theory of statistics that's called the Gaussian distribution or the normal distribution. And for a symmetric distribution, the mean, median, and mode is more or less similar. Theoretically, they are the same. So if I actually draw a theoretical distribution over here, a distribution like this, right? So basically over here, this is the mean, median, as well as the mode. So over here, this part is the mean equals to median equals to, right? So basically, the existence of a symmetric distribution means that the values of the variables are more or less homogeneous in nature. There are no heterogeneous values of the variables. Clear? Okay. So this is the relationship between the symmetricity and asymmetricity of a distribution and the measures of central tendency, right? So let's stop here for the day. I'll not take up further because the next part that I talk about is asymmetry of the distribution, and then I'll talk about the dispersion, because if I start it now, I'll not be able to manage to finish it. So we start with this discussion of fresh. I'll send over the recording. I'll host this recording on the Google Drive, and I'll send over this the PDF of this document to you guys today or tomorrow, so that before coming to the next class on Saturday, you guys are well prepared with or you guys have gone through whatever this is. So this is very basic stuff that we have gone through it today. Next class we'll pick up the speed much more and we'll do it in a much more concretized manner. We'll go to the more, we'll just explore it more technically. So before I close the session today, there is one quick question I would like to know. One quick thing, that are you guys comfortable doing this class at around say 9 a.m. in the morning, from 9 a.m. to 11 a.m.? Kumar, Anirudh, Prakash. Great. So, so Kumar, is it next week only? Okay. Okay. So what we'll do is, so next Saturday will be a problem for you, right? And Sunday onwards, it would not be a problem. You can do it after Sunday onwards, from 9 a.m. Okay. Okay. No, like that. Let's then keep it at 2:30 p.m. Yes, Prakash, it's 2 hours each Saturdays and Sundays. However, today is the first day. That's why I did not do so much. But going forward, it often it spills over to 2 hours, 10 minutes, 15 minutes, like that. So that tend to spills over. Okay, then let's do one thing. Let's have this class at 2:30 p.m. itself. I mean 2 p.m. itself. So let it be the way it is. Let's not confuse between Saturday and Sunday like that. Let's let it be this way. Also, just one quick question. Instead of having say 2 hours each, right? So would it be a problem if you guys could manage to have it at say around uh, 4 hours or say 3.5 hours at one go, instead of having on Saturday and Sunday separately? Great, great. Okay, so I'll work around the timing. So for the next week, we meet at 2 p.m. right, so 2 to 4, and then I'll update you on the date and the time. Okay, so then I'll set a time which suits everyone. Because what happens often is, going forward, because the course spans over 4.5 months. So what happens is that there are Sunday commitments which come out for people and all. So that is why I was trying to get a comprehensive slot if possible. Once I work that out, I'll let you guys know. So let next week we are meeting at 2 p.m. Saturday and Sunday. Thank you. Thank you, guys. Hope to see you next week. Have a great week ahead. Bye bye.